Good. Today we will be talking a bit about mobile testing. So we will be discussing the basics, and we will just see and get an idea of how it is to actually test some mobile applications and what is the difference between standard web app testing. Now, before we start with the actual contents of the lecture, we will have a little discussion. Yeah, Ra, if you can share the instructions in the live chat, thank you. So you will see some instructions right now in the live chat. Thank you, Ra, for that. So it's a warm-up game discussion, if you want to call it. It's basically pick your tests, and what you can see here is we have this sort of scenario, right? And this scenario, for example, that we can see here is we have a mobile banking app, and then the idea is that we are testing it, right? So, what do we want to ask and answer ourselves here? Which types of testing are most important and why? So, again, imagine mobile banking app, you're testing it and you're thinking to yourself, so what is the most important thing I should test and why is that so? So you can write down in the live chat 2, 3, 4 if you want, if you are innovative, types of testing that you would like to perform and give an explanation on why you would like to do that. There is also an example here you can see. So we have performance, so network testing here, different speed of transactions, usability, small screens, touch gestures, installation, updates of the application. So these are just some examples to give you an idea. You can use all the knowledge you have from the previous lectures here, so you can use any type of testing that comes to mind. There are no wrong answers. There are no specifically correct answers that we're looking for. This is just to open a bit of a discussion and get us into the contents of the lecture. So you can write down in the chat what types of testing you would do and why you would choose to do these tests on the mobile application. So you can start noting down in the chat. Also, if you have any questions, feel free to write them down as well. And again, this is not something that it's not like a quiz, it's just a discussion. So it's even better if you all have different approaches, different ideas of how you want to test the mobile app. So this is just to get an idea of what we will be talking about today as well. I already see some people are writing in the chat. So we're going to wait a bit. And once again, you can choose rather any type of testing. So you can choose if you want functional, non-functional types of testing. You can choose automation test scenarios. So any type of testing you think of. So it's not locked to specific types that you have to perform. Right. Gonna wait for a bit more, about a minute or two. See, because it does take a bit more to note down these types of testing, basically. And by the end of the little discussion that we will have here, you will also notice some interesting details that we will mention along the lecture later and some similarities. So this will also be some kind of reference that we can use later in the lecture. Okay, I already see Inas wrote his answer. So the ones that Inas noted down are database testing, security testing, and functional testing. For database testing, the reasoning is to ensure that users pull the right data when they log in and are trying to perform any transaction. Wonderful. That's fantastic. A great approach. And I would also say that this is a highly important test to perform. So, the point of the mobile banking app is to basically enable users to process transactions, to make payments for receipts for some invoices. So it basically works with their balance. So database testing, highly important. Very nice. I see for the security testing in a road to ensure that there are no vulnerabilities with logging in and with user accounts. Again, you don't want to have any hacks happening, so people trying to infiltrate others' accounts and then maybe even trying to steal from them. This is a very important type of testing, especially when working in the finance application ecosystem. And then functional testing, of course, to ensure that if a user logs in, they're able to do what they want seamlessly. So obviously, aside from the data, how it is stored, how it is secured, we also need to provide a good amount of user experience. So it's not only about making sure it's secure and working as expected, it's also providing a unique and, let's say, high quality experience for the users. So very well done, Inas. That was a fantastic answer and very much appreciate the detailed explanations. Then we will move on with Binu, who wrote that the important testings are security testing, performance, and usability testing. Uh, and I agree. So again, we see a trend going on here with the performance security testing and usability. If you want, Binu, I encourage you to also write down what would you do or why do you think it is important to do these types of tests. If you feel like it would be great. And I also see Daniel wrote unit testing used when you want to verify that individual functions components work correctly. Fantastic. Similar to other software, mobile applications also need to have unit tests. So this doesn't only apply to web applications or desktop applications, this applies to mobile applications as well. So the same way we do it for other apps, we do it for them. So testing everything in isolation, very important. Why? I also note here that you wrote down you chose because it catches bugs early, cheap and fast to run, ensures small part behaves correctly. Wonderful. Yep. Again, the principles for testing apply to mobile apps the same way they apply to other types of applications. So that's a very neat way to put it. So far, we have database, security, functional, performance, usability, and unit testing. So everyone, you're doing a fantastic job. I'll give a bit more time if somebody else wants to share any other types of testing that come to mind and why you would perform them. Again, there are no wrong answers, so um, this is just to see how everybody has a different opinion. So we see here we had a lot of different approaches to the testing. So there were some similarities, but again, everybody had their own take, which is amazing. But maybe somebody else wants to share as well. Also, I would note from my examples, for example, installation. This is not basically a testing type, but one thing that is very important is to check versions. This goes for other applications as well, but especially for mobile applications because they have newer versions coming out a bit more rapidly. So, one thing that I have been told, and I've also noted down is very important, is to test new versions instantly. And by installations, you want to try to get the updates on different mobile phones. So maybe your application version will be working fantastic on an iPhone 15, but when you try to install it on Samsung S24, let's say, it will crash, overheat the hardware, so cause all types of issues. So I would note down that part. And I see we wrote stability testing. Wonderful. Yeah. So basically, we can also note. Thank you for the wording. Actually, Binu, we can mention this as stability testing. So you get a new version and you want to ensure that it's running smoothly on different devices. That is ensuring that it is stable. So it's a wonderful approach as well. Great catch. All right. If nobody else has anything to add, thank you very much for taking part in this brief discussion. I love the ideas. I love the approaches. I can see that you're all already at a level where you get the gesture of all the fundamentals and base testing strategies, which is amazing. And today we're gonna see how they will support you and help you in getting these materials, let's say, mastered. So I'm now gonna share my screen. There we go. All right. Now, today, as I mentioned, we will be focusing on mobile testing. And the idea is you will also notice throughout the lecture, mobile testing in itself is not something that is vastly different from standard testing. So we're not going to maybe run into that many differences of how we approach application and software to be tested, but we are going to be talking a bit about different, let's call them ecosystems, operating system, general phone types. So we're going to explore a bit what is the difference in testing one operating system from another, because previously we were really not focusing that much on different operating systems because again, when you run something in a browser or when you try to do desktop apps, you usually have two options. In when you're working with mobile applications, you have a lot of applications for a specific only software or operating system and for another. So we're gonna get a bit more into detail about that. We're gonna talk about some automation frameworks and tools that are very helpful for mobile automation. And we're also going to understand a very key concept for mobile testing, which is emulators and simulators. And we will see what is the difference, when to use them, which is more applicable in everyday testing. And this is very important because for most mobile applications, these and remote devices are the way to go. So it's important to know what we are testing, on what we are testing it, and what are the results telling us, because sometimes we'll see later on some results could be redundant. We'll talk about a bit about that, and we'll in general talk again at the very end a bit about how it is integrated into CI/CD pipelines, and also what are some test steps and strategies that we can take when we are doing some mobile testing. So basically that is the gist of it. Do you have any questions? Okay, if there are no questions, I'm going to move on to the first part of this lecture, which is the mobile testing process. Now, we talked a bit about why testing is important in general, and we were talking a bit in the earlier software testing lectures. So based on all the experience that you have all gathered at this point, what do you think? Why do you think it is important to test mobile apps? So why do you think it is important to make sure that the application is working as expected on a mobile phone? What is your gut telling you, let's say? You can write it in the live chat if you want. I see some people are writing right now. Again, there are no wrong answers here, so this is just uh, trying to see how you're all thinking on the matter. I see being wrote higher number of users in the mobile platform. Wonderful. Okay, that's a very good take. And this is something I was actually also researching before the lecture. So, Binu, maybe you have seen my notes, but just kidding a bit. I see Nas wrote, everyone goes around with a mobile phone now and are always using apps and the internet. Wonderful. Yep, that's also a very important highlight to say when we're talking about testing. Pardon me. The Adam wrote, different types of devices. Wonderful. Yep, superb. Exactly. So basically, what you all wrote in the chat right now are one of, or basically, let's say as a whole, one of the most important things of why we have to do mobile testing. And maybe for those of you who are maybe not so familiar, in modern day, while the applications that we use on the web and our desktop, you could say that we're using more frequently for a longer period of time to do our job, etc. So yes, they do take a bit more time. It is quite interesting that people actually spent um, a lot more time focused when they're using their mobile applications. And a simple example is a lot of people are using Instagram frequently. They're more interested in the stories, maybe in the reels, YouTube videos, so on and so forth. So they take up a bit more time that you would actually expect. And while you, yes, in theory, you are working, let's say, 8 hours on Jira and your automation framework, when you take it in a total run over a month, you will notice that the mobile application time that you have been using actually it's a lot higher than you've actually been using any other application, which is really interesting. And when you think about it, in order to provide the best experience possible on those mobile applications, you have to do a lot of testing. And this is one of the most important aspects of it. I did a bit of reading for this in one article. I will make sure to note it in the resources that you have. It's a very interesting one. And we as QAs obviously need to make sure that people spending that much time on those applications have to have a seamless experience, or rather an excellent experience. So no UI issues, no performance issues, no accessibility issues. So everything should be made to perfection. And that's why QA has also been put as a discipline into mobile applications, or rather known as mobile testing now. Now, some of the points of why mobile testing matters are user experience. So, when you're using an application, the simplest way to put it is you don't want to, let's say, have a slowed loading time. So when you log in, let's say, to Instagram, you don't want to wait for 3 minutes. You ideally want to log in and be on the homepage or to your profile at the same time. So it's very important, especially for these small and compact apps. Then you have device diversity. This is something that actually Theodora mentioned in the chat. Different devices. So when you're working with browsers, essentially you're most likely going to get the same result regardless of what device it is. So if it's a Mac, if it's a Dell, if it's a Lenovo laptop, right, you're most likely going to get the same result on the browser. When you're talking about mobile applications, you might have one view or certain features available on Android, something different on iOS, something third on Xiaomi's hybrid HyperOS that is built on Android. So you have these distinct and different types of operating systems that you have to think of. So different devices is one of the most important things on why we need to perform thorough testing. Performance and reliability. As we mentioned, we don't want the application to take a lifetime to perform a simple task. We want to make sure that it executes everything to perfection and everything is seamless. So you want to have the best experience as possible. Following that, you also mentioned security in some of the example. Both Binu and Inas mentioned this. It's important to make sure that sensitive user data is handled properly, because a lot of mobile applications nowadays handle logins. So you usually have to create an account to make sure that all the progress that you have with the application is stored somewhere. So having high security is very important to have that trust factor from the end users. And then brand reputation. If you have a well-tested app, it performs, it's secure, it ticks all the boxes, then the reputation of the brand is secured. So you could have, let's say, an app, let's take, because we already talked a bit about Meta, let's talk a bit about Spotify. So you have Spotify, which essentially has a lot of neat features. You can listen to any song at all time. You don't have any latency issues. Everything is perfect. So basically, it's just like having all of the music available to you locally without having any issues with lagging or delays or bad audio quality. And then you probably have some other, let's say, third-rate app, which I have used on my Xiaomi phone, which I had, which frequently has some issues with the audio, for example. So the output that it produces, it's not at the highest level. So if you want to listen to more, let's say, heavy songs, you're probably going to hear a lot more, let's say, echo and distortion sounds than you should when you're listening to, for example, on Spotify. So you want to also keep the brand name high with the quality that you provide. So that is the, let's say, essence of the importance of testing in mobile applications. Do any of you have any questions so far? It's a bit more introductory. We're going to get into the more, let's say, detailed part right now. Okay, if there are no other questions, I'm going to move to the next section. Okay, types of mobile applications. Now, before we talk about testing the applications in detail, we need to understand what type of applications do we have on mobile devices. So similar to when we discussed different web application types, we also have the same situation for mobile phones. So you might have heard from some of these types, and we're going to discuss them a bit more into detail, but why is it important to know what kind of application you have? It is important so that you can structure your test plan in a way that it makes sense. So you don't want to have too little scenarios to cover what you need to test for your application, and at the same time, you don't want to go overboard. So if your application is native, you definitely don't need to check any features that are related to another operating system or maybe even to the web version of the application. If it's related to the web, then you're probably going to just need to play around with some styles and not so much with performance, for example. So it's very important to understand what type of application you do have and what tests are sufficient for your application. Now, before I move into detail on the different mobile application types, do any of you happen to know what are the types of mobile applications, or have you ever heard the term maybe native mobile applications, hybrid applications? You can write it in the live chat. Maybe you have come across the terms at some point. Again, it's okay if you have not. It's perfectly fine as well. That's why we have this section here. Okay, I don't see anyone writing in the chat, so we're gonna take this bit by bit. So when we're talking about mobile applications, we essentially are, I see in the live chat, Valentina wrote, I heard native, but not sure of the meaning. Yep, it's perfectly fine. We're going to explain it right now into detail. But yeah, I think there's a lot of times where people, at least in the past, were using native apps for mobile phones a lot. This is maybe like 9 years ago. So I thought maybe some of you might have heard it because at that point I also did I mean, I didn't have much idea. I just knew what the term meant as a definition, but we're gonna get into details right now. So the main types of applications you have for mobile, you have native, you have web, and you have hybrid. Each of those has separate characteristics. So all of them are, let's say, unique in their own way, and all of them have different cons and pros. So similar to web applications that we discussed. You can also notice a pattern here. So there's not so much difference between web and mobile application testing, and you will notice this as we go more in depth into the lecture as well. Now, what are native mobile applications? So as the name suggests, native are built for a specific operating system. So native, something that is only from one single place, only for one nation, let's say, as the name suggests. So they're only meant for one operating system. So native apps could be some that are only for iOS or some that are only for Android. Some that are only for Huawei's operating system because they have a separate thing going there. So you can say, for example, the Apple Play Store. Apple Play Store is an app, is actually the App Store, I believe. I might be wrong. So the App Store on Apple, if you notice, you can't really download it and use it on an Android device. So this is a native app. It means that the code is completely shutting off everything related to the Android operating system, and it can only function on iOS alone. So you will never be actually able to use the App Store from Apple on an Android device. Now, the good thing about these native apps is they're highly optimized. So they have a lot better performance compared to the other two that we're going to talk about. They have usually a better user experience, again, due to the amount of, let's say, work that gets done into them. And they usually have direct access to some specific features such as GPS, camera. You can also see it here in the material. So again, Apple's camera specific, let's say Samsung S24's camera, separate thing. So these apps can have access to those. And they can also support sometimes some features offline with local storage. So basically how you can remember the native apps: high speed, high security, top-notch performance, but take a lot more development and maintenance. So that is the drawback. So for example, it would be a lot easier to have like a shared code base and have your application work on an Android device and an iOS device in comparison to only working for an iOS device. And that is because some functionalities that are implemented in another type of application are a lot easier to use as a solution in comparison to the ones in the native one. And because this one is only for this specific operating system, you can't really use them. So you're not able to use them. You can try to replicate the solution, but usually it does not work that way. So native apps, high performance, high security, fantastic usability, drawback being that you have a lot of costs and a lot of development and a very much difficult maintenance after they're developed. So when you see the App Store being uploaded so rarely in a way, so you can actually notice that they don't have so much frequent updates coming in. That is because it takes a lot of time to just modify these things or add new features. And that's why sometimes you may notice when you use, if you have an iPhone, for example, the App Store, you will see that you don't have that many updates. So maybe you will see the layout, let's say, for the homepage changed every year and a half or two. These are just random numbers. It may be done in a year, but it's not usually that frequent. Same goes for the Google Play Store, for example. You might not notice it, but it does take a lot more time to have a, let's say, a larger update than other applications. Then let's say games even. Games do usually take less to update. So that is the gist of the native apps. Now, the other type of mobile applications are the web mobile applications. These ones are basically, I call them responsive applications. Basically, these are essentially web applications that have additional HTML, CSS, and JavaScript used so that they look good on a mobile view, so that the responsive view is, let's say, acceptable, it's solid. So the idea of a web mobile application is that you can actually develop your own web application. So you can have, let's say, Swagger, for example. And the idea is you have that application, but when you develop it, you don't really work on how it's going to look on an iPhone, how it's going to look on a Huawei device, on a tablet. So you're not really thinking about different viewports, about different displays. And when you add those JavaScript, HTML, CSS bits that do make it look good on those devices, you essentially have a web mobile application. So a web mobile application is the mobile version of your web application, put simply. So essentially, one thing I can show you for this, what am I referring to actually? I'm just going to pull this one tab here. I have it open. So I think you should be able to see it. So let me just turn this off. So how can you view the mobile version of a web page? And you can actually try this on your own if you want to later on. It's quite straightforward. You can right click on any page. You click inspect, as we were opening for the mobile testing, for the automation testing. And then in the bottom left here, where you have the, let's say, display or toggle device toolbar, it is called, you can actually just click on the device here, and it will show you this little let's say mobile view. It might show you some responsive view, but if you click here in the top left, you can actually see you have a lot of devices. And you can essentially check if the application has a mobile web app version. So what we are seeing here is a mobile web application. So if this didn't have a proper styling inside the application, this would probably look very out of place. It does look a bit out of place even now. You see, we have a lot of empty spaces. I can't see the burger menu all the time. If I open it, maybe something else happens. You see, we have a very, very interesting look here. But essentially, to give you an idea, this is what a web mobile application means. And if we go back a bit to the materials, they're basically platform independent. So this does work on iOS, on Android, on any operating system because it is connected to the browser. And they're actually very good to have because they have all the updates that you do for the regular application. So if you update your web page, let's say you add a new view for the shop page, let's say, it is also going to be updated on the mobile version. And all you'll have to do, add some styles, so do some minor modifications, and you're just going to have a functioning mobile version of your application. So while it is, let's say, easy to update, it is very limited into what features it has. So you cannot actually do all the things you could do with a native app. So you can probably not have some, they're called drawers. You cannot have some slider effects that you can add on those applications. They're a lot slower. So they perform the same way that the web application does, maybe even slower at some points. So the responsiveness, the speed, and just this power of adding all these unique features to mobile applications are not very available for these web applications. I see Valentina wrote a question, which was the option inside inspect? Yes, sorry. So the option is if you open it, so when you see this view like I have right now, so this is the inspect, you have console elements, and right next to elements, you have this little device here, this little dark device. And when you hover, it says toggle device toolbar. It might be different in Brave. This is on Chrome that I'm using. Chrome and Edge usually have the same. Yeah, and when you click it, it will give you this. Again, this is not very important for this bit. We'll talk a bit about it later on as well. This was just a demonstration. So, web mobile applications, again, very simple, straightforward. They can be updated frequently, basically the same way as you're updating your web application. However, they lack in performance, they lack in tools that you can use to optimize them, and their performance is a lot slower and not as efficient as the native apps. Finally, we move to the hybrid mobile applications, and basically these are using both technologies that you use in web applications and that you use in native mobile apps as well. So what is the idea? Hybrid mobile applications usually are made so that you can use them on both one operating system, another, a third, so maybe 5 operating systems at once. So that is, as the name indicates, hybrid. You can use them on multiple devices. And basically, you can use a lot of tools to make these applications. One very frequently used tool, and one I would say more modern, is the language Dart with Flutter framework. I can also send this later on with the materials. It's basically a mobile programming language that can make apps for iOS and Android and hybrid apps. So it can be actually combined to make applications on both ends. But the idea is that you combine the best of both worlds. So you have the elements that make the web pages unique, so you can have this fast update of your application, and then you have features that are only possible for the native apps or for the applications only for the mobile of that operating system, but you're extending to different operating systems. Now, they are definitely better than web applications in performance wise, but again, they're not as let's say fast and responsive as native apps. Again, native apps are usually the best at what they do because they're very let's say specifically catered to one operating system. And usually when you want to make something adaptable to other things, you need to modify the code and make it adaptable to that. So let's say Android is a bit slower than iOS, so you will need to make a bit of sacrifices in the iOS department speed so that you can match what Android can handle. So that's why these fall a bit behind the native apps. However, again, this is nowadays you might notice that this is the most common approach for mobile application development, and usually the applications that you will test will be either hybrid or web mobile applications. It's quite rare to actually test native apps, at least from my personal experience and from some other coworkers that we have discussed. Moving on, we will see some comparisons here. We already talked a bit about these differences as well, and about what are the capabilities of all of them. However, what I would basically try to let you know is this. So the native, as we talked about, only focused on one operating system. The best performing ones, however, take a lot of development and costs to make and maintain. Web mobile applications, the slowest of the bunch, but have the most frequent updates, and they are basically mobile versions of web applications. And finally, hybrid, they can be applied on multiple operating systems. They combine everything that is used to make a web and a native application, and that's why they usually lag a bit behind the native apps. So they don't have the best performance, but they have the most wide coverage of devices. So that is the best point of these hybrid apps. Do you have any questions so far? I see some people are writing in the chat. I'll give it a few more seconds before we move to the next bit. Sabine wrote, what about cost comparison? That's a great question, Minu. In terms of cost comparison, out of all of the three that we see here, if we're talking about mobile applications strictly, the least costly, let's say, is the web mobile application. And this is because, again, as I mentioned, this is just making slight adjustments to your web application so that it looks good on mobile. So essentially, you can actually just tackle this at the same time when you're developing the features for the web and just add some style changes, and usually you have a very, very good solution. So these, I would say, are the least costly out of all. But again, the slowest performance. So you're not going to get a mobile application per se. Then I would say is hybrid apps, because although you might think that, oh, well, you need to have people who know how to make Android applications and then iOS applications. But the thing is, both iOS and Android have some very interesting features that make life easier for the other. So you have like a short shared code base, let's say. You can reuse some of these things to shape the application. So in terms of cost, this would be second because you have so much availability to play around with the application, and that gives you a lot more time and cuts, let's say, the time you would need to research what you need to do to make it work on the operating system. And then the native ones are usually the most expensive, strictly due to maintenance and updates. So native applications, when you have let's say a bit big of a problem, let's say you can't process some transactions on iOS, let's say, it's a nightmare to even try to debug it and then to go and fix it, because again, you're not working with, let's say, a variety of tools at your disposal. You're just working with what you can for iOS. So these are definitely the most costly, again, because they take a lot more time to finish things. They take a lot more expertise. They take a lot more experience, basically, so that you can know how to fit those solutions. So cost comparison wise, I would say web first, hybrid second cheapest, and then the most expensive is native, definitely. No worries. Okay, let's do a quick question before we move to the next section. You can write down in the chat 1 to 4, A to D. What is the key disadvantage of web mobile applications compared to native and hybrid apps? Higher development cost, limited access to device features, require separate code bases, or difficult to update? So what do you think is the answer? You can write it again in the live chat, 1 to 4, A to D, however you prefer. I see Bin wrote B. All right. Let's see what everyone else thinks. I give a few more seconds. And if not, we're going to trust in the answer provided. I see other people are also writing. Jixing wrote B as well. Right? Yeah. And then we're going to go with the answer, which I see is what everybody is thinking is B, limited access to device features. We can check it, and that is the correct answer. So as I mentioned before, they are the easiest to update and the ones that you can actually work on the most changes, but they don't have all the features that native and hybrid apps do. So very well done to everyone for answering this correctly. Okay, now regarding mobile application testing, at the beginning of the lecture, you all gave me some types of testing that you would perform on the mobile banking app that we had as an example. Now, you already saw that all the testing types that you wrote down are testing types that we actually already covered. And the best part about mobile testing and about, let's say, the approach that it needs is that it is very similar to regular web application, desktop application testing. And why is that? Well, it covers the same types of testing that you need to do. And one day when you're working on a project, I want to just let you know that if you go into a project where you will solely be focused on mobile testing, it's nothing to be afraid of. If you have done the web application testing, it is the same rodeo, let's say. So you will perform the same testing types. The only difference will be that you will probably be doing it on a different display. You're obviously going to do it on a different display. You're going to be using a lot of devices, but the essence is the same. So first we have functional testing. And again, same as the web application testing, you want to make sure that everything functions properly within the application, that all inputs produce the corresponding outputs, and that basically the components of the app itself are doing what the user expects them and needs them to do. So what are the steps that are taken? Requirement analysis. So if you remember, this is also part of the testing plan that we had for for the basics of testing. You need to understand what are the functional needs. You need to design test cases. You need to execute them, and then afterwards perform regression when needed. And again, quite similar to what we were discussing with web application testing. Some common test scenarios include login functionalities, form submissions, payment processing, transactions accuracy, moving from one screen to another, because there's usually this functionality. You might have seen it on some apps where you kind of slide from one window to another. So that's also a functional testing because there are components that do that. So whatever you can think of as a function within an application, you can actually confirm by testing with with a functional approach. Then we have usability and user experience testing. So this makes sure that the application is user-friendly, that's intuitive, and that it's accessible. So intuitive, user-friendly, and accessible is something that's very important for mobile applications. And why is that? When you're working with web applications, Sometimes there is this case where you will notice that maybe the page is not as intuitive or maybe not as user-friendly, but you do have the ability to get around simply because you have a lot of things going on. The best characteristic of a good quality mobile application is for it to be simple, have as little as possible things blown out into the small screen of your phone, and at the same time to be able to let the user know what they need to do. And that's why it's very important to make sure that all these aspects are covered. So when you, for example, when you open Instagram, let's say, you don't have 50,000 things going on. You have stories, you have a post, and the chat bar, and then at the bottom, of course, the search. To look. But those are not that many features. If you compare them to some web pages, you probably have some 6 to 7 features at most when you're logged in. So it's very important to do that. And here, some key steps are to define test objectives. So see what are some UX improvements. For example, if you notice that maybe the stories are going out of proportion, people are feeling that, I don't know, they don't want to see that much information in front of them, you can definitely give suggestions like maybe removing them, adding an option to toggle them on and off. Other things are recruit participants. So you can actually take, let's say, a chunk of people who would do the testing, and they can actually, who are, let's say, the target audience for the app, and they can actually give you a lot of insights for these things because it's a lot easier than doing it with a web app when you can just distribute it to different devices and they can play around with it. Scenario-based testing, and analyze feedback or identify UI pain points and report findings. So basically, just note down some things that will need to be improved. Again, the UI and the UX is very important, especially for these mobile applications. Here are some common test scenarios. How easily can a user complete a task? So if I want to send a message, do I need to open 6 tabs or just click the chat bar? Navigation across different sections of the app. As I mentioned, you have that side scroll, you go from one page to another, or maybe you have a burger menu, it has sub menus, maybe you have too many sub menus, error handling, accessibility testing, and so on. Then we move to performance testing. And the thing that I want to highlight for performance here is it's quite similar when you think about it to web applications because you're essentially testing how the app performs under real world load. So you're not going to be thinking of specific scenarios only for mobile. The same that applies for a web app applies for a mobile app as well. So if Amazon needs to cater to 1 million users a day, so does Instagram, so does YouTube, so does the Play Store. So all of these have certain loads that they are expected to handle. Again, here you need to, for the steps, you need to set benchmarks. So what is your goal? What are you testing? Are you testing the spike? Are you testing how the app behaves through a prolonged period of time? And you simulate real world usage. You use specific tools to monitor how it behaves and then analyze some of the data that you get. It is a similar process of performance testing that we discussed earlier, and the types are literally the same. You have load testing, you have stress testing, endurance testing, spike testing. So all of these are types of testing that are performed the same way. You can actually also use JMeter for mobile applications as well. And I will highly encourage you to read a bit more on that if you have the time. It's a very interesting approach for that. And there are some other tools that support this as well. You even have some performance testing tools built in Android Studio, in Xcode. So I'm not going to go into too much detail about those because that's a bit more than you need right now. And one important aspect I would also mention here for the performance testing is network testing. So when you do performance testing, something that's a bit different for web applications is that you need to test how the app performs on different networks. Because when you're using a laptop, for example, you're going to use either Wi-Fi or you're just going to plug in a cable, which is the same connection, right? But for mobile applications, you're going to use Wi-Fi or you're going to use mobile data. So 5G, 4G, whatever you have on your device. So some apps perform different in different networks. So this is also one very interesting performance testing type. I will also add this to the resources. You can read about it. So you also need to do performance or rather network testing on how the app behaves with Wi-Fi and with mobile data. it varies a lot sometimes, and especially when the app is in beta and requires network access. One very common issue when you use mobile data, because it's usually the faster one, you can heat up the phone to a point where you can't hold it. It's a very interesting thing that occurs. And again, this is in very early versions of applications that require network connectivity, but usually due to its fast speed and the resources it takes up, 4G or 5G even worse, it really overheats the device. So you need to cater to that. That's a very important performance test. Then we have security testing. Again, similar to what we already saw in the previous lecture. So you want to make sure that it's not vulnerable, it doesn't provide unauthorized access, no data breaches. So you want to make sure that everything in terms of security is proper for the app. You don't want anybody to log into your, let's say, bank app, steal some information from your profile on Instagram, Facebook, whatever it might be, your mail. And again, it's similar. The approaches is similar to that of security testing performed in web applications, and you can do penetration testing, so simulate hacking attempts, vulnerability scanning, identify weakness in the app, static code analysis, check the code if you might notice some areas where something can be injected, dynamic analysis, find issues during runtime. Then we have compatibility testing. So this is to make sure whether the application works on different devices. Here also the network that I also mentioned falls under this category. So you want to make sure that it's stable on different devices. This is something that Binu mentioned at the beginning, stability testing. So this is basically it. It's referred to as compatibility testing. You can call it stability testing as well. This is just the wording as this. And the steps that you need to take when doing this is to see which operating systems do you need your app to support. If it's hybrid, it doesn't necessarily mean that you make it supported on all Android operating system types. So maybe you don't want it supported on HyperOS on Xiaomi. You maybe don't want it on a specific iOS version. Pardon me. Or maybe you want it available only for newer Android types. Maybe you don't want it to be applied on KitKat. You want it to be applied on the Marshmallow version of Android. So again, you need to see where you need your app to work. You need to set up the environments. You need to have the devices with the OS set up and ready for testing. You need to make sure that the UI and performance is there for all devices. So if I'm using, let's say, iOS 11 and Android 11, both should have the same result. So the app should have the same speed, same functionality, same throttling. So everything should perform the same at all times, and it should be of the highest performance. So again, this is a type, I would say, of functional and non-functional testing into one to make sure that different devices, different operating systems, and different networks support our application the same. Again, we don't want it to fall performance or functional wise when a different device is registered. And I would really say that this is the most important testing when it comes to mobile testing. So ensuring that it works on different devices does take a lot of time. You also do regression of functional scenarios here. You do regression of performance scenarios, security scenarios here. So this is, I would say, a very large process of compatibility testing that could take up for a new feature about 4 or 5 days of intense work, but definitely is worth the result that you get at the end. Okay, do we have any questions so far? I did a bit more talking, but it's the type of lecture that we have. Any questions about the types of testing for the mobile applications? Okay, if there are no questions, I will briefly go through some of the mobile testing tools that are available, and then we can have the break. So, mobile testing tools. We're not going to go too much into detail on how these work, so we're not really going to use any of these tools. Again, you can do more reading on them if you want in your free time. But these are essentially, let's say, the trinity of mobile testing. We have APM, we have SQY test, I call it X test suite, and then Espresso, Google's Android testing tool. Now, some of you might have already heard about it, APM. I would say that this is the Selenium for mobile testing. It's basically developed by the same party. And essentially, it is an automation testing framework for mobile applications, and it supports iOS and Android and uses the same protocol as Selenium WebDriver. So if you ever open it, you'll actually see it's very similar to Selenium. It basically does all the same annotations, except you have some differences in how you get locators. So it's basically Selenium for mobile, if you want to call it that. That's how I usually refer to it. And what it does is it supports cross-platform, so you can write tests for iOS, you can write tests for Android. It has different language support, so similar to Selenium. It also supports Java, Python, JavaScript, Ruby, C Sharp, various type of languages. It has no app modifications, so you don't need to modify anything in the app code to make it work. So essentially, you're just testing the UI of the app. You're just getting the locators for the elements, really similar to Selenium. And what is ideal for? It is ideal for apps that you want to run on iOS and Android, which are the hybrid apps. And it can check everything. So you can write tests, a test suite for iOS, you can write a test suite for Android. The most common practice when you automate these things is you usually have, similar to when we talked about the page object model, if you remember, you have one section, let's say, for your Android tests and one section for your iOS tests, and then they are both linked to the same steps. Because again, the application needs to do the same things. It's just the difference between how the locators are written in iOS and in Android. Then we have Espresso. I don't know if you've heard of Espresso. It's, I would say, not that new, but relatively new, a relatively new tool. Again, it is also an automation testing framework, which is used for UI tests, and it is created by Google, and it's only used for Android. So this is for native apps of Android. If you want to test native apps, I really recommend Espresso. It's a bit faster, I would say, than APM, and it is integrated with Android Studio, meaning that when you're writing code in Android Studio, you can actually write out the unit tests immediately. So you don't have a separate solution. You do everything at the same place. Again, it's a lot more faster than I mentioned than APM. It runs and executes the test a bit faster, and it reduces the need for flaky tests due to its needs. The best use cases for it is for Android-only projects that need to be officially tested and handled at the fastest amount of time possible. And this is mostly, I would also add, used for unit and integration tests. Although it does support UI testing, you can use it for UI testing definitely. Most often, this is what devs would use for unit or integration tests. And again, it's because it's very fast and reliable. So you have all these tests that are done beforehand in a bigger quantity. So you have a lot of coverage with them so that you can focus on the UI with the end-to-end tests with either Espresso, if your team prefers, or APM. You can use Espresso and APM both as well. So you can, that's also an option. And then we go to XQY test, which is Apple's version of Espresso, let's say. This is only meant for iOS, as the name suggests, and it is integrated with Xcode. Android Studio is the one used for development of Android applications, and Xcode is the equivalent, so it is used for iOS development. And it is very similar to Espresso, because it is integrated with Xcode. So again, this is something that usually developers use as well for unit and integration tests. So this is the main tool that they will use for this. And I would say, again, it's a lot faster than APM, obviously. That's why it is used for these unit and integration tests. But it is, I would say, also one of the main tools used for UI automation for iOS native apps. So this is the go-to for the UI automation because, again, it's very fast in comparison to APM because it's native. And I have used it a bit early on. I'm not a big fan of SQI test. I think APM and Espresso are a lot more intuitive than this one. But if you ever need to use it again, it's very efficient, it's very reliant, and is definitely a very powerful tool for automation testing. Now, when you want to decide on which tool to use, it will always depend on what your project needs. So, are you working on an application that needs to be tested on different types of operating systems? If so, you're most likely going to use APM because you want to have everything in one place, bottled up. You don't want to write separate tests in Espresso, separate tests in SQI test. So have two solutions. You just want everything in single place. And that will basically benefit from, let's say, the lack of speed in comparison to the other two. Then, if you have something native to Android, you can use Espresso. You can make it a lot faster, a lot more performative. Same goes for XQI test if you are using or if you're testing an iOS application. So it all depends on the environment and whether you have the option to add them. Again, these are more or less, APM is more or less open source, and Espresso and SQI test, if I'm not mistaken, you can double check this as well, do have some plans for some specific things that you can get out of them, but usually you can try all of them out yourself and you can see how they all operate. I see also Seraphim provided a very good in detailed explanation for both APM and Espresso, so thank you very much for that, Seraphim. And that's basically it for the tools. Do you all have any questions? Okay. If there are no questions, we have a little exercise here to do before we move on to the break. So match the mobile testing tools with their correct descriptions. So we have three descriptions and the tools here. You can write in the chat which one do you think goes which one. For example, A with Espresso, B with XQI test. So you can write it in the chat here, in the live chat, and I will drag and drop them based on what you answer. So A says a testing framework developed by Google specifically for Android, providing a simple API for creating UI tests. Then B says an open source tool for automating native mobile, web, and hybrid applications on iOS and Android. And then Apple's official UI testing framework for iOS applications with integrated with Xcode for writing and executing tests. I see Bean wrote A is espresso. Okay, wonderful. You can also write all the answers if you want. You don't need to, if you want, you can write one by one. You can write all of them at the same time, however you prefer. And then I will move them here in the column below and we'll check if everything is okay. I see some people are also writing in the chat. To give it a bit more time. I see Nas wrote A is espresso, C is XQI test, and APM is B. Okay, wonderful. See all the answers. I see an agreement for A because I see that I'm just going to drag it here as A. There we go. We'll wait for a few more seconds if somebody else has a different opinion, maybe. Okay, don't see anybody else joining in, so I'm gonna move it as both Binu and Ines suggested. So both of you have A for espresso, B for APM, and C for XQ test. And let's check it. And that is the correct order. So wonderful job to both of you for taking part and for getting the correct answer. That will be all for this part of the lecture. We will be continuing after the break. So Ra, you can take over for now. Okay, I'm gonna share my screen right now. Hopefully you can see it. So, where we left off before the break was with the mobile testing tools, and now we're going to actually see um, a bit how the entire process of testing applications on mobile actually works and what do we actually need in order to be able to perform this. Now, uh, when you have mobile apps, the first thing that comes to mind is to test them on a physical device, right? So you have a physical device, you have the application, you're running your tests either manually or you're just writing a script that automates the process, depending on which way you go about it. So the obvious first thing that you would notice when talking about mobile testing is using a physical device. So this can be a smartphone, tablet, so whatever you could have available to you. And the best thing about the physical device is that this is where you can get the most accurate results. So, in comparison to all other tools, it's ideal if you're going to have a physical device on which you can run all your tests, both performance, or rather non functional, and functional tests. And why is this the best scenario? Well, first part is that you have a realistic testing environment. So, the physical device is the real place where your application is going to be. So this is where the users will be accessing your application through. So you have all the software that you develop on the device, as well as the hardware, the operating system, everything else that is related to the application itself. So this is the most realistic scenario that you can get to test by having this device. Then you have accurate performance metrics, meaning when you have the device that you need to test, you will have a very accurate representation of how it performs with the application. So how is the battery usage? How does the hardware perform? So if you remember in the previous bit, I mentioned how some devices overheat when they're in early versions and you use mobile data. So this is the accurate performance metrics. So if you have a physical device, you will definitely notice this because you have the actual hardware with you. And then we have user experience, or rather you have the UX, let's say, testing that you can do on the device because you will have it in front of you. You will be able to do some user interactions that you expect to happen when the users access it through the given device. Now, while it is ideal to have a physical device for testing, it will not always be the case. One of the main reasons why you're most often going to have difficulties in having, let's say, a set of physical devices that you can test is costs. So let's say you have an application that you need to run on both iOS and Android. If you want to make it applicable for tablet as well, at the very least, you're going to need one iOS device, you're also going to need an Android device, and you're probably going to need two more tablets. Because, again, it's different what you see on an iPad and on a, let's say, Samsung Galaxy tablet, right? So, at the very least, you're looking at four devices for a single application. And when you take into account how much they cost, let's say you even buy them as used items, you're still going to pay a hefty price because it's not the point of having a physical device is not to just buy the older version and the cheaper version. It's to buy what is actually being used or it's quite, let's say, new for the application. So let's say right now, you won't probably get that much value if you use an iPhone 11 or an iPhone 12 for testing, but you will get value if you use an iPhone 15, if you use a Galaxy S24, 23, if you use an iPad or a new version, right? So you will have to at least have a hefty price in mind to acquire these four devices just for the application. Then you have maintenance. So these devices, although they're used for testing, you still need to update them. The operating system needs to get new versions. So you need to keep in check that. You need to have accounts so that you can use the application. So the maintenance bit kind of takes a bit more of a role there. And then logistics. So if you are in charge of those devices, so let's say at the company, they're all assigned to you, you will have a lot of more of a difficult time managing about maybe giving it to another team, or just making sure that everything is synced, all the data on all devices is correct, the application version is correct on all of them, and this can be a hassle. From my personal experience, the biggest issue is maintenance because on one of the previous projects that we had only iOS devices because that's what we needed to test. Um, and we had three iPhones. And the biggest issue I had with maintenance is the updates because we would get an update. It will usually have some, let's say, conflicts with our version. And two of the devices would have conflicts. The third one is okay. So maintenance is a lot more of a hassle than you would think with the physical device. However, accuracy wise, it will give you the closest and most reliable results out of all options that we will talk about. What is the setup? You need to acquire the device. So to make sure which devices you need, of course, then you need to prepare them. So install the tools that you will need for those devices, as well as the application, and then connect them either through Wi-Fi, mobile data, USB. So it depends on what you're going to be using to run the application, of course, where you're going to run it remotely. So this all depends on how everything is set up. Again, physical devices produce the best and most accurate results, but are quite expensive and take up a lot of times in terms of maintenance and logistics. Now, moving on, we have emulators. Now, some of you might have heard of emulators and what they are. They're essentially software programs that imitate the hardware and the software of a mobile device. Essentially, they are a virtual device. So it's a virtual device, let's say. And how do these devices work? Well, they give you, let's say, a pretty similar performance of how the actual physical device would perform, which is amazing because you don't need to go and acquire the device. You can use the emulator because you can check performance. So you can check how the hardware performs, you can check how the network connectivity works, and also test the software. And again, one of the best benefits is free or low cost compared to physical devices. They're very easy to set up and they're quite flexible. So you can actually change from iOS to Android in a second. You don't need to boot up an entire phone or have it up and running. So you can check something on the app there or start it on another device. You can just change the emulator operating system and you will immediately be taken to a different device. Some of the challenges here are that, again, it will not always represent the data as accurately as the physical device because, again, this is virtual. So it could sometimes have a slower performance. It could sometimes take more time to connect to the network, which, again, on an actual device might not happen. You don't have, you have a limited hardware interaction, so you can't really check the camera if your application is related to a camera. Let's say you have a scanner in the application, so you won't really be able to use the scanner as you should with a physical device. And again, as I mentioned, network conditions. So you might not always get the same representation of how the network operates on your emulator. And I also have an image here that I'm going to share. So this is what an emulator app looks like. Ignore the little text here. This is an image I downloaded just recently. This is the best one I found. And what you can see on the emulator itself is you're going to see the device that you're using. And on the side, you will usually have some information on the CPU, memory, disk usage, similar to Task Manager on your desktop machines or your laptops. And usually you might see something like Snapdragon here if you're using some kind of Samsung device, Android device. Basically, you're going to see how it is running. If it's overheating, this is going to have some kind of spikes. The memory might be overloaded. So again, you see you are essentially getting hardware and software performance of a mobile or tablet device on your computer. And this is usually the emulators. You can actually find them in applications such as Android Studio or Xcode, because when developers are creating the app, they can actually use the emulator to see how the app works. And you can actually also download the studios for yourself, get the solution, and run the emulator like so. And this is one, I would say, A not so common approach for software testing. It is something that is used actually for testing when developers do it, because again, they do have a lot more access to this. But if you want to get, let's say, more accurate data and you don't have any other means of doing so, this is definitely something that you can go for. So again, an emulator essentially is, let's say, it's a mimic of the hardware and the software of the device. So you can do performance testing here, you can do functional testing here, but it's not going to be as accurate as the physical device. Again, this is some of the setup, so you just need to install the emulator. Again, Android Studio or Xcode, they have some built-in ones. You need to configure them, so select which device you're going to run, change through them, and then you launch the tests. And here you can see we have a little graph depicting the difference between both of them. Again, it does not match the real device, but it does give pretty accurate, let's say, results. Now, moving on, we have the simulators. And the simulators oftentimes are very much confused with emulators. They are not the same thing. The simulator only replicates the software. So it doesn't replicate hardware at all. You're not going to be able to test performance if you are using a simulator. So you can only test the UI. You can only test how the application functions from a user perspective. So you can't check if it is slow, if it has good connectivity. You can only check if the drop downs work, if the menu works, if the search works, if you can click items. So this is the primary use of it. And it was primarily used on iOS at the beginning as well. And what are the benefits? It's way faster to set up in comparison to emulators. And I will show you an example as well of this. Development integration. So this included in Xcode, and it also, I think, it has support now in Flutter as well, so you can use it on Android as well. And then what is it best for? For quick UI and functional testing. So if you just need to browse through the UI, if you just want to make sure everything is working smoothly, best bet is to use a simulator because it's very fast, very reliant, and it does the job for UI tests. Before I move into the challenges, a simulator that you actually, I think, all have already saw in this lecture is the DevTools that we have in Chrome. So what you can see right now, we have this web application, right, opened. What we are viewing now is the responsive view, and this responsive view is actually a simulator. So the Chrome DevTools mobile view that we see is a simulator. And you see how easy it is to just change the devices. I can now take the pixel, it will adjust it to its size. If I want, I can try iPad Pro. You see, I will have the iPad Pro view. I can zoom in here if I want. And if you notice, I don't have any performance issues from a testing perspective. So I'm not really having any hard time clicking anything else on the screen. It's quite fast. It's quite responsive. I can change without any issue. And that is the benefit. So if you want to do some UI checks, strictly UI checks, functionality checks, simulators are the way to go. And they are quite simple to use, actually. So again, you will see when you need to use them. It depends on project to project. However, the challenges will be that you will not be able to test hardware. So you can't test hardware at all with simulators. So it's a no-go. If you really are reliant on battery life or the CPU usage or the memory or the RAM, you really have to use an emulator, a physical device, or a remote device, which we'll touch on later. So again, if it's just UI. Accuracy, it's not the most accurate performance-wise. So again, if you're looking for all aspects of the app to be covered, it's a no-go. And network conditions are not simulated as well. Regarding the setup, you just need to install the simulator software. If you're using some apps that are native or if it's something like a hybrid, you usually need to install something within Xcode. You can also do it in Flutter if it's for Android as well. You need to configure them and then you need to launch and test. It's quite straightforward. You can also, if you're using web applications, as I mentioned, most of the time, when you will be testing these web applications mobile versions, you're going to be using the inspect element, and you're going to be doing it like I showcased it earlier and in the lecture as well. So you're going to be using applications like this to essentially just go through them in this simulator. So this simulator would be more than enough for you when you work for web apps. So uh, this is something to keep in mind. Again, you're not going to test performance with this, but for UI, it's more than efficient. Uh, so that is basically the idea. Uh, I see a question from Binu. Is emulator the same as browser stack? That's a fantastic question, Binu. And we will get actually to that. To answer briefly now, it's not. It's not the same. And I will tell you in detail shortly, so everybody can be caught up and we don't confuse the others. But it's a very good question, so I will refer to it back when we get to that part. Now, one last thing that I want to note. When you're working on any type of project, it's very important that whatever you essentially decide to go for depends on what the project needs. So, what do I mean by that? If you are using, if you're only testing UI and you're testing functionality, you don't need to use a physical device that much. Of course, if you have the opportunity, I always recommend to have at least 2 or 3 physical devices if possible, even one. But if you don't have access to physical devices and you're thinking whether to use an emulator or a simulator, but you only need to test UI, always go for a simulator. It's really fast, it's really efficient, it does the job, and it gives the accurate representation of the device. If you need to test hardware as well, so if you need to test performance a lot, then and you don't have physical devices, opt for the emulators. It's slower, but you will get the performance test results that you expect so that you can make sure your application is working from a non-functional perspective. So, simulator only for UI, emulator, UI and hardware, so performance and functionality tests. Do we have any questions so far? I don't see any other questions. Okay, then we're going to do a brief knowledge check here. We're just going to go through the first question here. So what you can do, I'm going to open the drop downs and you can tell me as we go through the drop downs which option is true or false. So for each of these, we have true, false. And what you can do actually is you can just write the number of the question and then you can write true or false. So we can do it like that. So the first question is, emulators are software programs that mimic the hardware and software of a mobile device on a computer. So you need to tell me if it's true or false. Physical devices are more effective compared to emulators and simulators for initial testing. Again, true or false. And simulators are primarily used for replicating the hardware environment of a mobile device. Again, true or false. So you can write it in the live chat. You can write all at once. You can write them one by one, however you prefer. Just the number of the question and true or false, depending on what you think. We have a few more questions below, but in the interest of time, we're gonna focus a bit only on this one and then move to the next section. I see Daniel wrote the first one is true and the other two are false. Okay, let's see what the others think. Binu also has the same answer. The first one is true, the other two are false. Okay, we're going to give a bit more time for the others. Theodora thinks the same, so first true, other two false. Samson also wrote true and two false. I see we have already a little quorum here for what the answers are. All right. I don't see anybody else writing down, so I'm just going to select the first one as true and then both of the other questions as false. Now we're going to check. And there, that is correct. So emulators mimic hardware and software. Physical devices, as I mentioned, are the most expensive. So if they are cheaper than any of the other categories is definitely false. And simulators are primarily for software and not hardware. So wonderful. Very happy that you're all catching up with the materials thus far and for engaging in this exercise. Now we're going to move on to the next section, which is remote device testing services. So, what are remote device testing services? So, these are services provided by cloud providers, basically, like Azure, Amazon, Google. And basically, what they offer a solution to the problem of I want to test something on a physical device, but it's too expensive to get all the physical devices and it's very slow to do it on an emulator. So essentially, they give you access to actual physical devices through data centers, and you're able to actually test everything that you need from your application on a device, on an actual device, remotely. And this ties to the question that Binu had, is the emulator the same thing as browser stack? And I actually have browser stack open. I'm going to show you an example later. It is not. So remote device testing services are actually actual physical devices that you use remotely. So when you open them, it might look like it is an emulator. So when you first look at it, and we're gonna see an example later, it does look like an emulator. It looks similar to the image that I showcased earlier, but it's not. It's an actual device. So the results that you're going to get from the remote device is the same accuracy as the physical device, which is amazing and it's very useful because again, it's quite expensive to maintain all those devices, and these ones are updated by somebody else, managed by somebody else. All you need to do is to make use of them for your testing purposes, which is fantastic. So, what are some of the key characteristics? They're cloud-based, as I mentioned. So, you have a remote access to an enormous amount of devices and different operating systems, which are located in data centers around the world. So they're all at different spots. And depending on availability, you're able to access and work on all of them. I would mention this is similar to if some of you have used TeamViewer when you work on the desktop of somebody else. So think of it in that way. So you're just actually working on a device that exists somewhere, but you're accessing it through your own machine, basically. It has a wide device coverage. We will use browser stack a bit later, and you'll see it has uh, a very big library of devices that you can use. And that's only with the free version. And if you have a pro or a paid version, which is usually done through companies, you will have even more accessibility, a bigger session. So it's a very let's say useful tool. You have real world conditions. So you're actually testing under real world conditions. You can select different network types. So you're actually testing everything that you need to. You can see how the hardware behaves. You can see how the device works under different network settings. You can see how your application works with the memory, the CPU, so on and so forth. And scalability. It enables scalable testing by giving you multiple devices simultaneously. So you can actually change up and work with different devices at the same time, which again, it's very good. Some of the benefits of remote device testing is cost effective. So basically, you don't need to buy the devices that you will need to test, so the physical devices, and you will not really need to think about the cost that much because this is like a subscription. So these services are similar to other cloud services where you pay as you use. So whatever you need, you will pay for, and then what you don't need, you don't really pay for. Then you have convenience. So you have remote access to this library of devices. And the best part, from my personal experience, is that you don't have to do all the management. So you don't have to think about, oh, I need to update this, oh, I need to change that, oh, I need to take care of the device, oh, I need to provide my credentials. You have an account for the browser stack, for example. You log in, you just need to do your testing. So you get the maintenance part of the physical devices out of it. Comprehensive coverage. So Obviously, you will have a lot of devices at your hand, a lot of different browsers if you're using different, let's say, laptops, machines, operating systems, and whatnot. So definitely will have a lot more coverage than you can with physical devices or emulators and real-time testing. So you're actually doing this as at the moment. It's not something that is irrelevant to what you're working on now. Now, some remote device testing services that we will see are AWS Device Farm. Basically, uh, these more or less all of the ones that we will see function in the same way. So there are not that many differences. The differences might be more related to the layout or to what they support. So what is the gist of this one? It supports automated testing for APM, Espresso, XUI test. So you can run your automation tests here. It gives a lot of logs, screenshots, videos of test runs. It has live interactions with devices for manual testing. So you can do a lot of manual testing on mobile devices here. And it's best for development teams that need to test their application on a wide number of devices. So again, you will notice this trend for most of them, and the idea is to provide these features to all of us as testers. So a place where we can run our automated tests, we can get logs, we can get snapshots, we can have an interaction with these devices if you want to do manual testing. So this is all provided. Next is Browser Stack. And probably the most widely used one is Browser Stack. Again, it does support manual and automated testing. It can also be integrated with CI/CD tools, which is amazing. Currently, we have this done on the project where I'm working. So we're using Browser Stack for our mobile testing. And although the application is a web mobile app that we're testing, this really does help us in cross-browser testing for the application, which is very important. So we do actually test it on both iOS, Android, and on some specific Android versions. So I would say it's superb. It handles our mobile automation, and it also we have it integrated in CI/CD, so we have the tests for the mobile apps run automatically as well, which is amazing. Then we have Firebase Test Lab. Not so much used, but it is made by Google. It is quite, as I've heard, it is quite good for these types of remote device testing. Me personally, again, as I mentioned, I have not done that much testing in Test Lab. I have not used it that much, but it's similar to the others. It follows the trends of supporting automation, manual testing. It gives some analytic testing with Firebase, and then if you are, let's say, native in using Firebase, this is definitely the best tool for you. So, but again, these are all personal preference or what the project provides. In our case, we have support from Browser Stack. Previously, on the project at the other company, I worked with Device Farm from AWS. So again, it depends from project to project what you will have available to you and what you will be able to use. So it differentiates again, but any one of these that you're going to use, you will see a similar trend. So if you get used to one, when you change to another, it will not really matter that much because you will see the similar functionalities applied. However, I can say that most likely if you do have this remote device testing feature, you will be using Browser Stack since I think it's also the cheapest and it gives out the most options for us as testers and for developers as well. Now, one thing I want to showcase, I'm going to open one more tab. I'm going to move it here. This is how Browser Stack looks like. So when you go into Browser Stack, you're going to see this dashboard. You're going to see this big amount of features available to you. So you have testing toolkit, accessibility testing, website scanner. So you see you have all of these features that an emulator might not have. So the website scanner you might not have available to the emulator or the simulator, definitely not. You will have some options for in-app, so you can see here. And also, for example, here you have Android, iOS, you have devices that we can open up here. You have the browsers follow them that we can open. If I go to iOS, I can select the iPhone, I can use Safari, I can open that. And we see that it is booted right now. Again, what we're seeing right now, you're not going to be expected to do this. This is just a personal account I had for playing around. And you can also create one on BrowserStack. It's free, and you can check. You'll have probably shorter sessions, like I have 50 seconds for this one, but you can see you can actually uh, use devices that they have to test and play around. I'm going to stop this session for now. We can also open the app here and go app, let's say accessibility testing here. And if we wait for a few more seconds, because it's a bit slower, we're gonna start testing. Don't need this. So for example, I'm just going to use the iPhone 14 here, and it might also give me the option to select some applications. Let's see if it does. So if I've used up the session, it's going to open it. And once it's gonna load it, we can actually look at some applications here. You see it's gonna start on the right side. And now we can install the App Store, do this. You can upload your own app. So if you have some application, you can just put it here or install something via test flight. I'm not going to dwell too much about this. I don't want to take up too much time on the lecture on this. But again, this is the gist of it. So you have all these devices at the palm of your hand. You can make use of all of them. I'm going to leave this session now, and you can play around with basically anything you can think of in regards to mobile testing. It also has cross-device support, so it's not only for mobile devices. We also use it for Safari when we need to test on Mac. So this is which tool we actually use, and we have the Pro version, so we actually have normal sessions and we can test as much as needed. So yeah, this is basically a bit about BrowserStack. Do you have any questions regarding remote device testing? Okay. If there are no questions, I will continue to the test planning and execution strategy. Now, creating a mobile test plan. When we started the lecture, we started with seeing some similarities between web application testing and mobile application testing, and we saw very similar trends of things that were happening. So in the live chat, do you all remember what were some of the parts of a testing plan? So what were we doing inside the testing plan? What were we writing down? If you want, you can write it in the live chat. Again, you don't need to write the entire test plan, but some bits, if you remember, maybe something to test cases or execution, if you remember, from previous lectures, of course. I mean, this was a while back, so if you don't remember, it's also fine. We're here to kind of repeat a bit of the material so we can make sure that everything is done. But the testing plan for mobile testing is similar or rather the same as web application testing. So the first part is to define the goals of the testing process. This is similar to what we had for web app testing, where we got information gathering and defining scope, right? So we want to make sure what are the goals of our application. Ensure that it functions correctly, verify that it provides a seamless experience for everyone, identify bottlenecks, ensure data security, gather data, and basically see what are we aiming to do with the app. Then we have determined the scope of testing. So what do we need to test? Do we have to focus more on the operating system, browsers? Do we need to focus more maybe on the hardware? So maybe we're making a app that is dependent on the camera. So we might really need to focus more on areas considered with that hardware and not so much with the software. Is the lens good? So is the processor working properly? So you need to define what is the scope that you will be testing. Then identifying the resources required for testing. So you need to list the roles and responsibilities of the testing team members. If you remember, we talked in test management, you have test manager and the tester. So this is essentially that bit. Specify which tools you're going to be using. If it is a native app and we have automation tests, are we going to run XUI test for iOS or Espresso for Android? Or do we have a hybrid app? Are we going to use APM? Is it a web app? So we need to see which tools are, let's say, applicable to our application. Then devices, obviously, are we using physical devices? Do we have a remote device, a testing strategy, or do we need simulators? Again, based on what the application needs. So this is, I would say, one of the differences in the test plan, because here you're focusing on what mobile devices you need and tools for mobile testing. Then creating a timeline for testing activities. So start and end activities for each testing phase, setting thresholds or milestones. So what happens at which point, what should be finished at which point, and allocating time for test case development, execution, and reporting. Then we have developing of detailed test cases. So if you remember, this was the same for the web application testing. So we need to create test cases, which we will follow when we execute the test. So to make sure that everything is covered when from the requirement side and the user experience side as well. Then we have setting up the test environment. Again, so you might need to configure the devices, emulators, remote devices with some specific add-ons. So maybe you need to install the application beforehand. You might need to set up some files for your automation testing. Again, it all depends on the approach that you're doing. You need to make sure that also you simulate the correct real-world aspects. So if the app is not meant to, let's say, use mobile data, you want to make sure you're testing only with Wi-Fi, so you don't want to go overboard and just go and do some testing with mobile data when it is unnecessary. Identifying potential risks and mitigation strategies. So risk analysis, if you remember, you're essentially seeing if you have any risks for your application and thinking of strategies on how to mitigate them. Remember, so the risks were not definite issues, they were just potential places where those issues might arise, and finding the correct approach for them is definitely essential. Finally, define the reporting and documentation process. Similar to the standard test plan, after everything is done, we should see how we will log and track defects. So how we will have, what's the mechanism by which we will log and have everything noted down, how we will be structuring our reports, what do we need to put inside the report, will we use screenshots, will we only use logs, will we be using maybe some specific format for the reports, and of course, document all activities that have happened throughout the testing lifecycle. So essentially, it's quite similar to the testing plan for the web application, with the preparation being different because it's a different type of application. So as I mentioned, in web apps, we didn't really need to stress too much about different devices, where here we have a lot of different mobile devices, different operating systems that influence those devices. So the preparation here is a bit different. However, everything else usually stays the same. All right. Do we have any questions regarding the test plan? I don't see any questions in the live chat. Okay, then I'm going to continue with the defining test cases and test scenarios. Again, this is something that we have already talked about, test cases and test scenarios. Basically, when you're working on a mobile application, it doesn't matter that you're not using it on the web. You still need to have some kind of guideline from which you will be working on when you're testing the application. And that guideline is, again, test cases. Now, we already talked about what are the key components of a test case. Just to refresh our memory, we had a test case ID, unique ID for each test case. The description gives us information on what we're testing, preconditions, so everything that must be done before we can test what needs to be tested. We have the steps, So what do we need to do in order to make sure that this feature is tested? The expected results, so what should happen, and the actual result, what happens. If that doesn't happen, we should also update the status, whether it has passed or failed. So if expected and actual results match, we know that the status will be passed, and otherwise it is failed. So essentially the test cases follow the same, let's say, structure as they did with the web page test cases. Now, regarding the test scenarios, uh, they are again high-level descriptions of what we're going to test, and they show us an overview of how the app should behave. So again, it is the same as when we're talking about web page applications. So how do we create the scenarios? We check the requirements. We see what do we need in the requirements. We make kind of a summary for ourselves. So once we review everything, and we identify what are the main functionalities. So if I have 10, let's say, requirements, we usually group them and make out the main functionalities. Then based on those, we create user stories. So we write out a sort of ticket in which we describe how the users will interact with the application. Then we map those journeys. So we map how those journeys will all play out. And then we essentially have our scenario. So our scenario could be the user searches through the shopping page of the application. That is one scenario, so a valid search. Another scenario would be the user tries to buy a sold out item. Another scenario would be the user tries to open a sub-menu item from the hamburger menu. So essentially, it's like a collection of steps that need to be taken for which we will have test cases that the user would perform. Finally, we have a prioritization of the scenarios and making sure that we understand what should be taken into account first before the next. So what comes first, what comes last, based on, of course, the priority that we have set in the requirements and our own understanding of the application. So again, quite similar. I know it's a bit repetitive, but it's quite similar to the web page testing. So we have the scenario, we have what is supposed to happen, we have it well defined, and we have it prioritized. And based on that, we create our own test cases. So you have this very nice comparison here of the test cases in the scenario. So test cases conducted on a tactical level, and this is on a strategic level. So tactical is referring to just covering the scenario that we have, so how we will cover the scenario, and then strategic level means that it's basically how everything should be done, so what is the entire flow. We can see multiple differences that we have here. I'm not going to go too much into detail because we've already talked about this topic quite well, but I'm just going to try to summarize it that we, despite that we're just testing mobile applications, again, we need some kind of guide. We need something to show us how we recover the bigger picture. So how we will be executing the test essentially, and that is the test cases, and they follow the same recipe that we talked about in web application testing. And then the thing that those test cases are following is the scenario. So we need the scenario to be well defined, well structured, to outline user interactions with the page so that we can understand what needs to be done, what needs to be covered, what we will be, which steps we will take in our test cases to make sure that that user flow is covered to, let's say, perfection in a way. So, do we have any questions regarding the test plan or the test cases and scenarios for mobile testing? I know that you're all already familiar with these testing concepts, but again, it's worth to be noted because again, they are repeated regardless of what kind of testing you're doing. So mobile testing, web app testing, desktop app testing, game testing. So you always need these guidelines. Okay. If there are no questions before we move to the break, we have a little question here, which is defining test cases and scenarios. Again, you can write true or false in the chat, or you can just write one or two for which option you think is correct. A test case should include a unique identifier, a description, preconditions, steps to execute the test, expected results, actual results, and test status. Do you think it's true or false? Again, you can write it in the live chat. I see people are already writing. Daniel wrote true. Okay. Let's see if others might think even otherwise. Bean also wrote true. Vivi also wrote true. Okay. Again, we have an agreement for the answer. All right. If there are no more answers, I'm going to select true. And that is the correct answer. So these are the building blocks, which we've gone through a few more times for the test cases. And we're well done to all of you for taking part. It just reassures that you have an understanding of what the test case and scenario actually are. So well done for that. Before we move on to the next section, we will have the last break right now. So yeah, Raya, you can take over. All right. Welcome back, everyone. Hope you had some time to refresh during the break. And let's get through this final bit of the section for mobile testing. So we left off at the manual mobile testing bit. Now, um, we have obviously, like all other types of testing, both manual and automation testing for mobile applications. Now, in manual testing, it's obviously going to be us as individuals trying to go through the steps by hand. So it will be essentially going through the application items and checking whether everything works as expected. It is similar to when we were doing some manual steps for the web applications. So same goes for the mobile apps. We're just trying to uh, do as a user would, but with a bit more detail, with a bit more structure, and with a specific set of steps that we follow in order to make sure that those functionalities are working as expected. Now, the key characteristics for manual testing are human interaction, exploratory testing, and ad hoc testing. Now, human interaction uh, basically instigates to that we try to see whether essentially we're just doing what the user would do. So human interaction. We're trying to see whether we can navigate through the app, whether if we do some specific tasks, we will cause some kind of error. So essentially, imagine what a user would do. You're just doing it instead of them, but with a bit more of a let's say, idea of what you're trying to achieve. Exploratory testing, it is the same as with web application testing. We're just trying to explore the application to try to see some new behaviors that have not been there before. Essentially, we're just trying to see how the application would behave by doing things that we have not done before. So same with that web application testing. And then we have ad hoc testing, which is a sort of informal testing. You don't have any test cases similar to exploratory testing. This is usually just in a way done to check some items that have been implemented just recently, and you're just trying to test based off experience and intuition. It's usually done by, let's say, more experienced testers because usually they have a wider range of domains that they have tested. So these features on mobile apps especially can be added ad hoc, so without us having any time to prep for these features, and having the experience, having the, let's say, tester's mindset, you usually go into the feature and try to test to the best of your abilities without a specific plan. So it's similar to exploratory in a sense that you don't do any preparation, but it's also a bit of let's say, guided testing because you need to work based on your experience. Now, I do have a question uh, for all of you. You can write it also in the live chat. Uh, do you have an idea of what type of testing would you do for each characteristic? So let's say, what would you do as a human interaction? So what manual tests would you do there? So what would you try to do in a mobile app if you were to do some human interactions? Or what would you do if you were exploring the app? So let's say you have Instagram. What would your train of thought be? How would you test it? you can write it in the live chat. For example, me personally, I would, for human interaction, first and foremost, try to see if I can click everything. So that would be my first test. Yeah, exactly, Valentina. Like scrolling, opening menus. So you can do anything. Imagine you're opening your mobile application that you're testing now. What would you do? So for human interaction, what would you do, let's say, or for exploratory testing? As I mentioned, for exploratory testing, some of the things I would personally do is try to find items in a menu that I've never seen before or have never opened, let's say. And I would go there and I don't know, maybe try to see if everything is clickable. I would also see um, if let's say uh, the UI elements are correctly ordered. So what first comes to eye. ICB wrote do some test in chat, uploading pictures. Wonderful. Yeah, wonderful. That's both that can both fall in human interaction and it can go in exploratory testing. So maybe when you try to send a JPEG image, it would crash. It's too big of a size, so it can't be sent. So you need to fix that. So that could happen. Any more examples? I see some people are writing in the chat. Do check the app is crashing on new updates. Yeah, excellent. Yeah, so you can actually check if it crashes on new updates. You can open the app and play around with it when you have an update. Usually that's the way to go about it. You have um, so for mobile apps, sometimes you don't have the standard smoke tests when there is an update. So you might not have like a set of tests that you also perform because sometimes the changes to the application can be actually very different from what you had before. So when a version comes online, you usually do a sort of regression exploratory testing combination for mobile apps. So this is a very key feature, and then you usually just go and try to uncover other things while you have the new version. So that's also a very neat example. All right, yeah. So basically those are, let's say, the bits and parts that you can take and do when doing manual testing. And then some of the steps um, that are done in the manual mobile testing process are the test planning, which we already went to, the test case development. Again, we discussed it in the previous section. Test environment setup, test execution, and defect reporting. It is the same process that we have as web applications, with the difference being the prep. So we have mobile devices, we have different operating systems. So again, it's very important to remember these things for when you go into real projects and keep them in mind. Now, what are some of the benefits? Real user perspective. So one of the benefits from manual mobile testing is obviously we provide quality, we provide trust in the application. We also provide insight into actual user experience. So once we do some exploratory testing, we can actually also give insights on some things that we might have not, we might have missed when it was in development phase. So maybe once you do some exploratory, you might notice that some drop downs are not in line with the styles. Maybe some are outdated, so you can give some more insights on that and you can modify the app to give it even more quality. You can also explore the app so you can pinpoint some locations where there could be some issues that can occur. Again, this gives in turn the supports the left shift approach of testing, which we talked about previously. So it helps us to make sure that basically we are covering everything as soon as possible and offers feedback on usability and design. Some of the challenges, it is time consuming. So imagine doing exploratory testing quite a while. So it does take a lot more time, especially if it's not automated. So this is one of the drawbacks. You have human error, so you could sometimes miss some things when you do these types of testing, even especially when you do ad hoc testing, because again, this is not something that you are doing um, with some plan prior. You're actually doing it on the go based on your experience. And then scalability. It is difficult to scale apps due to frequent updates. This is something that I mentioned earlier in the lecture. You have these updates that are coming along quite frequently for some applications, so it is hard to scale them when you have these incoming things at all time. Do you have any questions regarding the manual mobile testing? I see Daniel also wrote how a user, checking how a user taps, swipes, navigates, and interacts. Wonderful. That's also a very good example. And this is usually the basic, I would say, test that is usually done for mobile apps because, again, these interactions are what most frequently happens on these apps. Okay. If there are no questions for the manual mobile testing, I see some people are writing. I'll give it a few more seconds. And if not, I will move to the automated mobile testing. All right, now we talked a bit about manual mobile testing. Now we will briefly touch on automated mobile testing. Similar to web applications, its goal is to support us in making us more efficient, reducing the amount of time that we will need and effort to manually cover different aspects of our application. So essentially, it is similar to what we did in web applications. We want to be more efficient. We want to have less human error. We want to make sure that everything is working as expected and also increase our own productivity at the end of the day. The characteristics are the same. We have efficiency, consistency, and scalability. So again, we're automating everything that we do manually, meaning we're making it more efficient. We are having a better outcome of the results because the automated tool will give us consistent results and it is scalable. Now, the steps in automated mobile testing are, again, test planning, test case development, environment setup, execution, defect reporting, and tracking. It is the same as the manual one. The difference here being that within the planning, we also have to talk about which tool we're going to use, which devices we need covered. So if we're using a native tool, do we want to use a native automation tool? If we have a hybrid app, do we use APM, for example? So basically, which one suits us the most? We develop test cases or we reuse test cases from our manual steps for the automated tests. We set up the environment, which is usually either emulator, devices, simulators, remote devices. So again, we said this depends on the project. We execute the tests and then we generate reports with the automation solution. Now, one thing I would note for automated mobile testing, although you might see that it's quite trending right now for people to be automated testers, and I do believe that moving forward this will be more required from testers. Um, Mobile testing is still more manual than it is automated. And this is not because it's difficult to automate these tests, not at the very least. This is usually due to some more setup that you need to have done so that you can automate the scenarios in comparison to web applications. For web applications, you just install your IDE, you install the frameworks, and you're good to go. Here, you probably need to select specific devices, you need to change them, you need to make sure that everything is properly set up in your code base, in the remote tool that you're using, or in your emulator, simulator. So it does take up a lot more time to set up. But again, comparison to the manual testing, in the long run, it does provide more efficiency and reduces the amount of time you need. However, for the setup, again, it does take a bit more time than setting up automation for web projects. Some of the benefits that we have here is that it executes tests much faster than manual testing, which is obvious. And it's actually, you can actually see that it's a lot faster in comparison to this difference of speed in manual and automated web page tests. Because here you'll usually have, as I mentioned, either some remote devices or emulators, simulators, and these are a bit slower, let's say, when you're testing them at those occasions, and the automated test will just speed run that. Reusability, so you can actually reuse your tests similar to the web page application tests on different versions of the applications, and you can actually reuse tests in different OSs, so in different operating systems with just a few tweaks to locators and some methods. Also, they have a very wide coverage, which can only expand over time. For the challenges, as I mentioned, we have the initial setup. You will need a lot of time to just set up the devices that you need and the overall environment. So it's not as straightforward as with the web automated tests. And then the maintenance, again, you need to update test scripts, but other than that, you need to maintain devices, or rather, you need to update devices. You need to make sure that what you're using is relevant. When you change that, some of the tests might fail. So you need to make sure to check, is it due to the device? Is it due to the application? So maintenance here is a bit more chaotic, I would say. And then complexity, uh, aside from the test scenarios that are complex, um, just taking into account the maintenance and then noting down which scenarios should be automated is complex in itself, especially for mobile applications. So these three are essentially the only cons you would get for mobile automation, and the sole reason for why, again, there's still more manual testing for mobiles than there is for automation. But again, I really do encourage, if you have the opportunity to work on automated tools for mobile applications, to do so, because again, if you have seen one automation tool, you will basically be adaptable to any other. So it's quite straightforward. Okay. Do we have any questions regarding the automated mobile testing? Anything related to also the test cases, or okay? If not, I'm going to continue to the executing tests on multiple devices and platforms. Okay, so we talked a bit about creating a test plan, test cases, manual and automation testing, and now we're moving on to executing tests on multiple devices and platforms. Now, when you develop, as I mentioned, even in the beginning of the lecture, when you will be working on mobile application development, more often than not, you're going to be testing hybrid applications. Even if they are not hybrid applications, so let's say they're native, you will still need to have a good device coverage. So if your app is native iOS, is a native iOS app, that doesn't mean that if you test it on, let's say, iPhone 16, it will work on the Pro version, or it will work on the Pro Max version of the 17. So you have to have a good device coverage. Now, that doesn't mean that you have to take 15 devices or all devices possible for the application to work, but you should have a good amount that kind of solidifies the quality of the application. Now, we mentioned, so before I move into this section, we mentioned that uh, we have these different types of applications. All of them have different devices, obviously, due to the operating systems. But it's also important to understand the devices that we have themselves. So, uh, if you remember at the beginning, I talked a bit about how some devices are irrelevant. So, older devices like iPhone 11 might not really do it justice to run the application on them, because they might have no updates in one more year for their OS, and the application will not be able to function. So that's why some of the key considerations for the devices include device diversity, platform specific features, and network conditions. So when you want to test across different devices, you need to take these into consideration. So if you're testing, let's say again, an iOS app, you don't want to test it on the versions of the 17 and the 16. Let's say at the moment, the best, or the, let's say, the most future-proof devices are from the 14 Pro Max till the 17, right? So you would want ideally to have a 14, 16, 17 Pro, let's say, and that would be enough. You don't need to have all devices, but you have different series, different software, different hardware, you have different performance. And that way you have device diversity, and you have a wide coverage. And because you have them and you have different operating system on each, you will notice how the app behaves in different environments. Rule of thumb is if it performs well on iOS, let's say 10, 11, 15, 13, it will most likely be performing good on the others because you have a pretty good coverage of the operating systems. So having different devices is crucial when you want to do multiple device testing. Again, device diversity does not refer to the one version of the device in different formats like Pro, Pro Plus, or Plus. It means different versions. So Samsung, S24, A56, iPhone. So you want to have different aspects of the devices. Then, platform specific features. So you have iOS universal links, you have Android intents. You need to make sure that platform specific features are covered, especially when your app uses them. So if you have some platform specific features that your app utilizes, let's say Apple Maps. So Apple Maps is specifically integrated inside your application. You want to make sure that all the features it provides are working as expected. If it doesn't, then you might run into many issues. One issue could be that you won't be even able to see the map because due to that feature, you're not able to access the functionality at all. So you want to make sure that platform specific features are covered. And one of the most important aspects is network conditions. So when you are testing different devices, you also want to see how they perform in different network conditions. So nowadays, it's a very big trend to just use mobile data if you're outside, especially. So you want to make sure that you cover different bands. You want 4G, 5G, if still applicable, 3G as well, and you want to check for Wi-Fi connectivity. So different network conditions make the app perform differently. As I mentioned earlier as well, a lot of issues are discovered in network conditions, especially when using mobile data, because 5G uses a lot of resources, for example, and if your app is in a very early state, you will definitely run into major overheating problems, sometimes not even being able to connect to the internet due to it not being able to provide the resources for that. Now, regarding the steps that are needed to execute tests on multiple device platforms are the same ones that we already covered in manual and automated testing. So we have the test planning, test case development, environment setup, execution, and defect reporting and tracking. The ones that I would focus the more on here are the test planning and the environment setup. So why? Well, what is the difference? When you have different devices, you have to incorporate them into your test plan. So this is the ideal scenario. Sometimes you might not be able to due to time restraints, but if you have the opportunity, you should list what devices you're planning to take up and just to have a clearer picture for yourself what your coverage will be. Most of the time, you will have guidelines on which devices you need to use. So usually it is the clients that will say, okay, we're only going to expect users to use iPad and maybe Samsung mobile devices. So if that's the case, you usually devise your plan around that, and you make sure to include devices from those types. So types of iPads, Pro, Mini, Air, and some Samsung Galaxy phones, right? So in the planning, it's very important to note down which devices make sense for you to test. Again, if the client decides that um, you you don't have any users that will be using different versions of iPhones, it doesn't make sense to really load them down and test the feature. It will just be a waste of time. Now, regarding the test environment setup, again, this depends from the client. If you're using emulators, uh, they take usually forever to load, so you will need to prep well ahead of time before you begin the testing so that everything is ready so you can just dive in and do your testing. Ideally, and again, most projects nowadays use remote devices, even physical devices sometimes. For those, it doesn't take that much time, but again, you still need to have the app up and running. You need to have all the features necessary and the testing tools that you're going to use. So you have to be ready at all times for that. And the simulators are the easiest to configure since you can just use them, for example, through DevTools. So again, you just need to note down what you have at your disposal at the moment. Take into account the time needed to set up everything, especially when working with emulators, because again, they take a lot of time, and just prep all the tools that are necessary. The other steps follow a similar trend of the other types of testing that we mentioned before, and essentially it is the same flow that we saw multiple times. Now, benefits and challenges. Some of the benefits include improved user experience, market reach, and higher quality. So obviously, when we're well prepped, we have a wide coverage of devices, we have done our manual or automated tests, the quality and trust of the app are on the highest level. The challenges, on the other hand, are resource intensive. So even if you do have the, let's say, remote device software, so let's say you're using Browser Stack, you would say, okay, all of the devices are available to me and I just need to change and test through them. The difficulty of why it's resource intensive is if you have 4 devices, you need to run all scenarios on all of those devices. That ties into time consuming. So if you're testing, let's say around 15 test cases, you have to technically test around 60 because you're testing 4 devices. You need to make sure those work on different devices. It does take time, especially when you can't automate it, let's say. If you do automate it, again, it does reduce the amount of time it takes, but it's still a bit complex. So it has to work on an iOS, it has to work on an Android, it has to work on a Huawei operating system. So those are the challenges. You have to use a lot of resources, it takes a lot of time, and it is quite complex even if you automate it. So you have to think about multiple things at the same time. You can relate this to cross cross browser testing, for example, when you run some tests on different browsers. The thing is, it's more complex because here each system is a story of its own. For example, the browsers might not have that many differences, so they don't usually. So you don't have to do too much in-depth testing, like repeating each step on every browser. But here it's very important that each test case and test step is executed on each different device, because again, the results will most of the time differ. You will have issues, and then you need to work around them. Okay. Do we have any questions regarding the executing tests on multiple devices? Right? If there are no questions, I will move into the integrating into CI/CD pipelines section. Now, as I mentioned, we are actually able to integrate our mobile test into CI/CD pipelines. So this is usually performed when we have automated test scenarios. So when we have mobile test cases, this is usually not the case. And it's quite, I would say, preferred to have it integrated into a CI/CD pipeline because these tests are run automatically. Now, I know we spoke a bit about how challenging it is to always just set up the environment, do the tests, even if they are automated. This is only the case when you're trying to make sure if your tests are working, if we're talking about automation tests. So when you need to check if your scenarios are correct, if your tests are executing correctly, you will need to go through these steps. However, when we have everything integrated into our pipeline, then we don't really bother too much with going through the extra steps of running all these emulators and simulators because it is taken care of for us. Now, if you remember, the acronym CI/CD stands for Continuous Integration and Deployment. So what does the continuous integration allow us? It automatically builds changes, meaning that if you're working on some test scripts, let's say, and you make some changes, so you have now changed it, you're now making them to be applied to 5 more devices instead of 3, they will be automatically applied. So you don't need to do this um, every time you have this change, and then those are automatically run. Then the continuous deployment bit tells us that tests are built automatically and they are deployed to different environments automatically. So again, this is a step that we definitely don't need to go over. And the best part about this in mobile automation testing and why I believe it's very important to have it implemented in these types of tests is because, again, it's very troublesome, especially if you want to check the UI, how it is operating when you run your automation tests. Um, you want to have a mechanism that will automatically do all the checks and tests at certain points, especially for repetitive scenarios. So you don't want to be opening the device remotely or the emulator, depending on what you're using, and just running your scripts all the time to make sure everything is working. If that can be automated, you can evade that step and just get the results. It's ideal. So this is what the CI/CD does for you. Now, how you can integrate it, you need to set up a CI/CD server. Again, don't need to worry too much about this. This is usually configured on most projects. So even as beginners, you won't need to do that at the early stages. Maybe at later stages in the career, you can get into this. And then you need to configure it to trigger these builds and tests. You need to have some kind of trigger that makes this automation start. Then you automate the build process. So you write some kind of scripts that will build the application for different platforms. Again, most of the time this will be done by somebody with more experience. And then you make sure that the build process includes dependencies and configuration. Then you integrate the automated test with depending on the tool that you're going to use in the pipeline, and then you make scripts that will basically run your scenarios. So you can also add some kind of tags in your script. So if you have smoke tests, they are the only ones that are run. Or if you only want regression tests to run, you might add tags for regression. You specify that in the script. Then you do some continuous deployment, which basically you build everything for other environments, and then everything goes on to the next environment if all goes well. And finally, you obviously have monitoring and feedback, so you get an idea of what is happening, if something is failing, why is something failing, what could be causing the issue. So this is usually all done in detail. And the parts I would really say that will concern most of you when you begin with your career of testing is just going from the automated testing to the monitoring part, because you will be updating the automated tests, you will be doing the runs, and you will need to see what basically is happening with the build. Usually these things sound a bit complicated now, but when you look at it practically, it's quite straightforward. So the automating testing bit, you just a trigger is run and you just see how everything is executed. You don't do anything really. And then if there are issues, you usually just get errors. Those errors will tell you what is the issue. And uh, at that point, you try to debug, you try to see if it's something related to the tests or if it's an issue or a bug in the application. And then that continues to be, let's say, distributed with the remainder of the team and look together with devs and DevOps aligned. There is this example integrating mobile testing with Jenkins. You can see it says stage build, building the application, and test is running the tests, it's deploying. So this is a fairly straightforward example. Usually you might see maybe even hundreds of lines set up like this, but the idea is that there are steps and those steps do some kind of action for our scripts, basically. Do you have any questions regarding the integration with CI/CD pipelines? I don't see anybody writing anything down. So I'm gonna go into the conclusion. So basically today we discussed the basics of mobile testing. We saw what is the process of creating a test plan for a mobile test, going through the process of manual and automated mobile testing. We talked a bit about why it is important, what are the different applications that we can test, what are some approaches to the different types of applications, and most importantly, we discussed a bit about how we can execute those tests. So we talked about emulators, which were hardware and software, rather virtual devices that we can use for testing. Then we have the simulators, which are very lightweight, only simulate the software and are quite fast and quick for efficient for UI tests. Then we have physical devices, which are the optimal solution when provided, of course. And then we have the remote devices, which are provided by cloud providers, which can be used to simulate a dozen of these devices with both hardware and software and network and all aspects of them intact. So we talked a bit how we can go through them, what options we have, and again, mobile automation testing is not only concerned with mobile apps. We also saw we can do it with web applications, mobile versions. From my personal experience, I can really say that you will most likely, if you're working on mobile apps, strictly be working with hybrid applications, and most commonly you will be doing mobile web application testing because when you're on a web application, you will definitely need to check the mobile version of it. So that one will be quite common. But from a mobile strictly perspective, it will be hybrid applications. So you will be able to see some of the differences in what happens on an iOS, on an Android, and how everything comes together with the hardware and the network in different perspectives. Does anyone have any questions in general from the lecture today? Anything at all? If not, I'm going to, just a second, going to open the Kahoot and you're going to be able to see it. Let me just do it like this. I think you should be able to see it on my screen now. We're going to do the mobile testing Kahoot before we end the lecture. And we're going to get the code right now. So we have the code here. You can enter it and join the room here. And thank you, Raya, for sharing the link and the code. So you can all start joining the Kahoot and let's see how everything went with today's lecture. I encourage you all to take part because again, this is just a revision. It will help us to solidify what we saw in today's lecture, and we will also be uh, able to even learn from some mistakes that we will do in some of the results for the Kahoot. So it has a good learning curve. Also, if you have some issues with reaching the Kahoot, please let us know in the live chat. I'll wait for about a minute if somebody else decides to join, and if not, we'll start in the interest of time. All right. I don't see anybody else joining so that we can finish everything on time. I'm gonna start the Kahoot, and if you're a bit late, you can also chime in. You can write some of the answers in the live chat and we'll see if that is the correct one for those of you that might join late. So let's start. All right. Let's see the first question. Which mobile testing tool is best for automating tests on both iOS and Android using the same API? Let's see what you all think. I see answers are already coming through. So both iOS and Android. Okay, I see most of you got Appium, which is the correct answer. I saw some answers for Espresso and JUnit. JUnit was actually a framework for unit testing, which is separate a bit from this for the mobile testing. And then Espresso was the one developed by Google strictly for Android. So this is strictly for Android, but it did have a mention of API, which is an API that is used for a simplified UI test. So I know why it can get confusing, but nevertheless, good job to everyone. Let's move to the next question. What testing ensures smooth streaming app performance across various devices and networks like 3G, 4G, 5G, and Wi-Fi? Right? So we're talking about network here. Keyword. So see, most of you got compatibility testing, and that is correct. Basically, compatibility makes sure that the application is compatible with both the devices that is used, the network that it also uses. So it is okay to use it with 4G, 5G, Wi-Fi, which is wonderful. All right, let's move to the question number 3. What app type would deliver top performance and full access to device features like GPS and camera on a single platform? So on a single platform. I see majority got the native app, and that is correct. As I mentioned, the best and highest performing apps are the native apps. I see somebody wrote progressive web app. We never mentioned progressive web apps, but no matter what type of web mobile app it is, it will still not perform as well as native apps due to the performance things that they themselves with the device and the operating system allow. Let's move on to the next one. So, which of the following is an advantage of using simulators? So, keyword simulators. What was the simulator used for? All right, I see a mix of answers. The correct answer was speed and ease. This is because simulators only show us the software performance. So it's only software specific, and as we mentioned, it's only good for UI. Ability to test hardware was with emulators, remote devices, and physical devices. So emulators are the ones that can be used for hardware. And I know it's a bit confusing at the beginning, so this is a normal thing to confuse at the start. And then real world network conditions. Again, for this, we would need to have a remote device or a device present so that we can actually check the network. So they are ideal for speed and ease of setup. Still all doing terrific. Let's move on. Which of the following is a limitation of using emulators for testing? It's a bit more tricky right now. Wonderful. I see the majority got the limited hardware interaction, and that is correct. Although they do simulate bits of the hardware, you still can't get access to everything, like cameras, scanners. So this is something that's off limits. And then we also have an answer in incompatibility with multiple operating system versions. Usually emulators can support different operating system versions, so this is not so much of an issue for them. All right, let's move on to question 6. Which performance testing type is focused on evaluating how an app performs over an extended period? So this is more of a performance testing question, but we also talked a bit about this. Let's see if we remember some of the concepts. I see how most of you wrote endurance testing, and that is correct. We mentioned endurance, meaning as time goes by, it still performs strong, firmly, it's stable. So this refers to endurance testing. Stress testing was a bit going over the limit of the application, so it's not really related to how long it is being tested. All right, you guys are doing fantastic. Let's move to question 7. In a CI/CD pipeline for an Android app, which Jenkins stage should run automated tests using Appium after the build? So which one should run the tests after the build? It's a bit more tricky. I see most of you got the test, and that is correct. So the build was done prior. Deploy means that it's going to the next phase. Monitor is only for monitoring, and then test is the action that actually runs the tests. So well done to everyone. Let's move on to question 8. What type of usability testing ensures users with color vision deficiencies can navigate your app? So what type of usability? I see all of you are in unison for accessibility, and that is correct. It is accessibility. There was navigation here to kind of try to confuse you a bit, but you all managed to guess it correctly, and that's wonderful. We have two more questions. In a mobile test plan for a large project, which section lists the specific devices, operating systems, and browsers for testing? So which section in the test plan lists the browsers and operating systems and the devices? I see most of you got the scope, and that is correct. So in the scope, we define what we will have for testing and where we will be testing basically for mobile apps, what devices, which operating systems, browsers, so on and so forth. So this falls under the scope. Whereas in the test cases, you can mention this. So for specific test cases, you can mention that you're going to perform a test on a specific setting, but the scope generally covers everything that we will have for it. Right, let's see the final question. Which of the following factors is not typically monitored during performance testing of mobile apps? So which one is not monitored during performance testing? Keyword performance testing. Let me give you a hint. See, most of you got user reviews, and that is correct. User reviews is something that is basically could be part of the app. So people review how the app is performing. But CPU consumption, because I see there's an answer, is actually part of the performance testing. So you can actually see how the CPU performs during performance testing of a mobile app. So this does fall into that category. And then user reviews could be a function, or it could be something external, which again does not fall under the category of performance testing. So that will be it for the Kahoot for this time. I want to thank you all. Congratulations to Daniel for third place, to Theodora for the second, and then we have a number one. Let's see, me. All right. So